And there are also some other creatures that are laying down, to some extent, are laying down calcium carbonate. It's not just the corals themselves. As a matter of fact, coralline algae probably contributes as much, if not more, to coral formation than the coral itself does. But there are a number of organisms that actually do contribute to calcium carbonate deposition. And if we're looking at the organisms that actually form calcite, these tend to be the foraminifera. We've already seen these before. These are single-celled organisms. Brachiopods, which are a kind of mollusk, bryozoans, ostracods, and there are some calcareous or calcium carbonate depositing nanoplankton. And there's also a type of protozoan called tintinids, and all of these things will actually deposit calcium carbonate on a reef in the form of calcite, of the mineral calcite. Now that's some form, I said some foraminifera deposit calcite, but most of them actually deposit they actually deposit a magnesium containing calcite. So they may contain between 4 and 20% of magnesium, replacing the calcium. And echinoderms and red algae also produce this kind of a coral reef, or contribute to the formation of this kind of coral reef. Now, aragonite is produced by most corals. The other kinds of things that contribute to aragonite reefs are green algae, cyanobacteria, mollusks, most mollusks, stromatoporoids, sponges, and radiolarians, however, actually produce opaline silica. So they're actually depositing, rather than calcium carbonate, they're actually depositing silicon dioxide. But we don't see a lot of that in the reef, and it tends to be internalized. When you do see silica in the reef, it's not on the outer part of the reef. You actually have to kind of drill into the reef to find the silica. But you do find a small amount of silica in corals. Basically, I think that one of the things that we have to be really aware of is the fact that there are things that are occurring in the environment that can be very, very deleterious to coral deposition, and we have to really watch out for this. And one of the things that actually there's been some recent experimental work done that suggests that it's possible to actually use electrical stimulation to produce corals. When corals begin to die off, they found that actually attaching electrodes to the coral and applying an electrical current actually encourages growth of new coral. So that might be one thing that could be used in some areas. Of course, you can't use a very large amount of electricity, because that would actually probably be fatal to most fish. But if a small current is actually passed through the water enough that it doesn't actually harm other creatures, it is possible to actually trigger to actually trigger coral growth. And it's felt that what may be happening is that the electricity, the extra electrons in the water, are actually causing increased ATP production. And because this is an energy intensive process, the coral deposition, having more ATP may in fact actually contribute may actually enhance coral formation. But I actually think myself that perhaps it may just be an effect that if you have two electrodes in the water, the negatively charged electrode, that is the cathode, should actually attract things like calcium ions and magnesium ions they should be actually attracted to the surface of the electrode. So that that may actually aid in sequestering these ions and acting as nuclei for new growth of coral where there are living coral polyps. So that's another possibility as well. But I just wanted to pass on this information